Hi, everybody, and welcome to the new edition of the HbbTV webinar series. There is a lot of interest today in this topic, the wave test environment for HbbTV and ATSC, because we have 125 people registered to watch this live. So this is really a great reflection of your interest in this topic and shows us that it was right to prepare this as the first webinar of 2023. So thanks again for tuning in today. And don't worry if you missed bits of it or if you've got colleagues who didn't have the time to watch it live. As usual, there'll be the YouTube recording for you on the HbbTV YouTube channel, and also the presentations will be made available for download as usual. I'd like to welcome today the speakers. First of all, Bob Campbell, Director of Engineering at Resillion. That's a new name you might not be familiar with. It's a former company, Eurofin's Digital Testing, you're probably familiar with. And Bob is also the chair of the Improving Interoperability Task Force of the HbbTV Association. Hi, Bob. Good to have you here. We have Jörn Piesing, Director of Standardization at TP Vision. TP Vision, if you're not familiar with the name, is the brand of the manufacturer of Philips branded TV sets. And Jörn is also the vice chair of the HbbTV Association. Jörn is not with the video here at the moment. He's got trouble with the webcam, but Jörn's audio is working. So Jörn will definitely be joining us. There's also Louay Bassbouss, scientist and senior project manager R&D at Fraunhofer FOKUS in Berlin. Hi, Louay. And last not least, is ladies first, but this time we're doing it differently. Jiang, senior software engineer at Resillion. Hi, good to have you.
Hi, Leif.
Okay, before we get started, as usual, you can submit questions through the Q&A feature of the software. So please have your questions coming in throughout the presentations. We will collect them. And in the last 15 minutes of this live session, the speakers will be happy to respond, give you feedback on your questions and comments, and hopefully maybe even some suggestions that you have for improving things. So we're looking forward to that. And before we get started, the disclaimer first, the presentations represent the views of the presenters and their companies and not necessarily of the HbbTV Association. Let's get started with you, Bob, over to, I think you're in Bristol in the UK, is that right?
That's right, okay.
Yeah. Let's get started.
Thank you.
We'll share his presentation.
Yeah, I'm ready to go. Thank you. Yeah, I'm very pleased to be here and to present and bring together this panel. I'm going to just do a little introduction explaining the CTA Wave project and hand over to my speakers in a moment to give a little bit more detail. I just want to show you a little bit about the Wave project first and foremost, if I can bring the screen up. And the Wave, let me just get that in front if I can. Can you see the screen okay? I can't see.
Yes, we can see the Wave project.
Okay, sorry, I couldn't see if you can see it. So the Wave project is an initiative really from the Consumer Technology Association, and they set it up to, as it says here, try and improve how internet delivered video and devices work together for the use of content creators and those trying to distribute video to successfully deploy services on a range of devices, from browsers to embedded browsers on applications on devices. And as many of you should be aware, the HbbTV Association referenced the CTA Wave specifications in its own specifications, and similarly the ATSC organization has, in its new ATSC 3 spec, also made reference to the CTA Wave specs. So they're very important for a whole range of different media platforms, but HbbTV and CTA have both made HbbTV and ATSC have both made specific references to the CTA specs. So we're going to hear now from Jörn Piesing, who's going to explain a little bit of the reasoning behind that. Why have those organizations brought those specs into their reference set? He's going to speak from an HbbTV's perspective, but the same reasons and background and requirements apply equally across to ATSC and probably other platforms. So I'll hand over to John now, and I'm going to try and show his slides on his behalf. If I can do that correctly, we'll be very happy. There we go. Hopefully you can see the start of John's slide deck, and over to John.
Hopefully you can hear me as well.
Yeah, I can hear you fine, yeah.
Right, okay. So in terms of the slides are about referring to the CTA wave tests. So I'll say a little bit first about referring to the CTA wave specifications. So historically, HbbTV referred to a basket of web specs produced by the former OpenIPTV forum. That was made in 2012, 2013. They dissolved, and we took over some of their activities as the HbbTV Association, but that document was never updated. And the web moves on, web browsers move on, and CTA Wave produced a Web Media API Snapshot, WMAS. That was produced in cooperation with the W3C to capture the state of the art on desktop browsers at a particular time. So there's a WMAS 2018, which is the state of the art of 2018, and so on. And HbbTV refers to a slightly out of date version of this, because browsers for TV sets are now on the bleeding edge. They don't follow the PC desktops in terms of really closely. Okay, so if we can then go on to the first slide on testing. This one, so where we come to, and this is sort of an aspiration, something we discussed in HbbTV a lot, is about testing the integration, the porting of a web browser onto a TV. It's assumed that the basic web functionality works because you're using code on a desktop browser, but the porting is not tested. We don't have tests for web standards in HbbTV. So yeah, there's a gap. So if we go on, keep going. So for example, the behavior of the video element is a gap. We don't test some of the things around graphics, which quite frequently will be handled differently on a TV. And the aim that Louay will talk about in a bit is how to use the W3C, selected W3C tests and the CTA WMAS test runner to fill that gap. So that's one of the CTA Wave projects. If we then go on to the next slide. So another thing they're working on is video playback, and tests for video playback. So, I mean, we all know how important how critical that is to HbbTV applications. And if you look forwards, W3C media source extensions, MSE, are by many to be the future of media playback for HTML. And so you build those, you use those with players that are JavaScript libraries, which have a number of advantages. So if we go on, so for example, apps can include the right version of the right library for their requirements. You can support recent versions of Dash and align with the JavaScript library more recently in the TV. A few examples. I mean, I think many of you will already be familiar with Dash.js or Shaka Player, or even HLS.js for HLS. So if you look at the W3C MSE tests, they really only test the APIs. They don't test system integration. They don't test different codecs. And they were created to meet W3C process requirements. So they're not really maintained except for the odd new feature. So what CTA Wave has done, if we go on to the last build up. Yeah, so CTA Wave device playback, it basically goes into a lot more depth. There's a sort of carefully thought through and considered set of behaviors that are used by JavaScript Dash player libraries, better coverage of multiple codecs, and support for automation. And that's what Jiang will go into in a bit more afterwards. So that's the quick intro to what the projects that CTA has done and why they add value to HbbTV. So with that, I turn over to the next speaker.
Yeah, thanks, John. And for anybody who is interested to find out a lot more about that, as I say, the website is here. They have links to their specification, the test suites, some background reading, and so on. The test material and all of that is done as open source projects, so it's all available in GitHub. And I encourage people to have a good look through this material if you're not familiar with this and the specifications. Right. Next up is Louay Bassbouss from Fraunhofer FOKUS, who's going to give us an explanation of the work that they've done on the W3C web platform test runner to extend and test the HTML browser environment on embedded devices. So over to you, Louay. Thank you.
Thanks, Bob and John. I hope you can hear me.
Yeah.
Okay, great. So let me select my screen to share my presentation. So
that's good.
So I hope you can see it now in full screen.
Just taking a second, I think.
So you should see my screen now, I hope. Or still not in full screen?
Not in full screen, no. It's still on the edit view.
Okay, let me do. Okay. Let me share again. So now you should see in full screen, I hope.
Yeah.
Yes. Okay, great. So hello, everyone. My name is Louay Bassbouss. I work for Fraunhofer FOKUS, and I will continue with my presentation and focusing on the Web Media API snapshot test suite. As Jörn already introduced, you can see on this slide a little bit more on the Web Media API snapshot. As you can see here, it's not only one specification and it's updated annually. On this screenshot, you can see is a one for 2022, and basically this specification is developed as part of the CTA Wave project in collaboration with W3C, and it lists web APIs which are relevant for media applications and that are supported on 4 major user agent web code bases like Chrome, Chromium, Safari, or WebKit, Firefox, and so on. It only references existing applications. So there is no new, existing specifications. There is no new development on new specification. It's like a set collection of existing specifications relevant for media applications. It's not only W3C specification, but there are also other specification groups relevant here, with, like ECMAScript and WebGL. And for each of the Web Media API snapshot specifications, there is also a test suite which is developed within the CTA Wave project based on the web platform test project. And I will go in my presentation in more details on this. So on this slide, you can see the big picture. And it's important to understand that we don't develop this from scratch because it's a huge amount of APIs and testing effort. The web platform tests already provide a cross-browser test suite for the web platform stack. So we take this as a basis and we extend it for running tests on embedded devices like TVs and set-top boxes. In my presentation today, I will focus on these three components, and later Jan will introduce DPC test suite. Starting with web platform tests, as I mentioned, is a cross-browser test suite for the web platform stack. Is developed within W3C. It's a huge community of developers supporting web APIs and web standards. Basically, to summarize it, it's built for desktop, or the focus is on desktop platforms. So you have tests which are requiring mouse and keyboard. There's also multi-window if you want to run tests, so it will open multiple tabs in your browser and run tests and so on. All the tests are hosted and persisting results locally. And one of the disadvantage of the web platform tests is it's very hard to run on embedded devices. And this was basically our motivation within CTA Wave project to extend the existing WPT test runner in order to support embedded devices like TVs and set-top boxes. As you can see on this slide, we extended the WPT server. We call it Wave Test Runner Extension. And this basically takes part of the test runner, which usually run on local devices, and move this part to the server. So we have at the end a lightweight test client, which can run on embedded devices, on TVs, on set-top boxes. And all the test configurations and integration is done within a companion screen application or companion screen page. As you can see here, when you run the test on a TV, you will get, like on the landing page, a QR codes that you can scan with smartphone, and it will open up a configuration page where you can do select the test you want to test. You can decide if all APIs or only selected APIs. But more important also that you can select tests that are like that pass on desktop web browsers. I will talk about it in a minute. So this is basically the core test runner. It basically enable to run all WPT tests on embedded devices. And another update also on this, when you run the tests and the tests are completed on device under test, you can basically quickly generate reports, HTML reports, JSON reports. You can export and import them between multiple test runner instances. As you can see here on the screenshot, this is what you will see on the companion application or companion page where when the tests are running on the TV. So you can remotely monitor the test progress and download test reports immediately for all APIs which are completed during the test. And when the final session is completed, you can also export it as zip file and use it in other platforms. I forgot also to mention that the extension of the test runner also provide a REST API, so you can easily integrate the Wave or the WPT test runner with existing tools and platforms and integrate it in other workflows. An important aspect is also during the development of the WPT and Wave extension, all the extensions and our contribution is merged back and contributed back to the original WPT project. And this is done also for each new version of the WMAS test suite. So when we have a new update on the Wave extension, we contribute this update back to the WPT project. And as you can see here on the screenshot, this is from the original WPT project. There is a new command that let you start the test runner for embedded devices using a new command which is called WPT serve wave. The Web Media API test suite is basically built on top of the Wave core test runner. So basically, it defines a subset of WPT tests, because WPT includes all the tests for all web APIs standardized within W3C. And the Wave test suite, because the Wave Web Media API snapshot only reference a subset of the web APIs, so it's important here to also define this subset in the test runner. What is also important that we already integrate external test suites like ECMAScript and WebGL in one single test runner, which is very important, because when you run the test, you will run all the tests in one single session. You don't need to switch between different test suites. And we do all the validation on different platforms and devices, especially on HbbTV and ATSC terminals. On this, I put it on this slide also links to the WMAS test runner and Docker zip deployment. So we offer Docker deployment for you. If you want to use the test runner, you can easily deploy it locally. But there are also hosted versions of the different test suites. So if you don't want to host it locally, you can use the online test runners. If you go to the GitHub project, as you can see on this screenshot, you will have all the links which are relevant for you in order to access the specifications, the test runner, and the Docker deployment. An important aspect is also in WMAS API, there is a huge amount of tests. I don't remember all the numbers, but from WMAS 2021, there are more than 35,000 test files. And this is a huge amount of tests. If you want to run all this on devices, will take a lot of time. And because for existing specification, HbbTV and ATSC specification, you don't necessarily need all the different APIs. For example, you don't need necessarily to test all the ECMAScript tests, which are also, there are a huge amount of ECMAScript tests you need to run. So you can also, there is a new project supported by Eurofins and BBC, there is a definition of the subset of WMAS tests, which are only relevant for ATSC and HbbTV, and in the future we may have other subsets for other specifications, but currently there is a subset for ATSC and HbbTV. So this means if you run this subset on the WMAS project, you will get less amount of tests as in the original WMAS test suite. So when I share the slide, I will share today the slides. You will have all the URLs you need to know about the different specifications. As you can see on this slide, there are different WMAS versions from 2017 to 2022. WMS 2023 is also in development. And you have also URLs to the online test runners, so that you can also try it by yourself. This is just a small demonstration how it looks like on HbbTV terminal. This is an HbbTV terminal. So you saw on the first landing page, you had a QR code. So the test is already started via companion screen, and as you can see, all the test assertion are run in a sequence on the HbbTV terminal. And yeah, it depends on the selection and number of APIs you selected. it may take few minutes or sometimes few hours, depending on the test you are selecting. You can also, there are some features, you can also pause tests, for example, and resume them again later, and so on. This is a very short demo on how it looks like on HbbTV. It's very simple. It's also fully automated. And maybe an important note here, it's not only the way how you do it via QR code and scan it and configure the test via a companion page is the only way to run the test. You can also run the test programmatically from other like platforms and workflows via the REST API. So that's it from my side regarding the test suite. And if you allow me to make some advertisement on two events which will take place in Berlin in June this year. I think you already, or many of you already participated in the FOKUS Media Web Symposium. So the event will take place again this year in June. So you can mark your calendar. You are invited to join in our institute in Berlin. So you have here URL with all the information you need. And if you have questions, please let me know, and I can support you. And another event which is very relevant also to the discussion today is about a joint Plugfest between Deutsche TV Platform and DTG and HbbTV testing group, which will be one full week of testing and Plugfest, which will also take place for the first time in our institute in Berlin. Thanks for your attention. And on this slide, you can find my contacts. If you have a question, you can ask later in the Q&A, but you can also reach me at any time later. Thank you.
Thanks, Louay. That was very helpful, and yeah, definitely worth highlighting the Interop event. The HbbTV Interop events have been very valuable, and we're very pleased to see those kicking off again. The next part of this presentation is from my colleague Jiang from Resillion, who, as was noted, has worked extensively on the extensions and some novel tooling that augments the test runner that Louay has just demonstrated to add automated observations for the device playback capabilities test requirements that are defined by Wave. And in addition, as Louay hinted, Jörn's been supporting the HbbTV testing group at the tooling to support the subsetting process for these tests, for the HTML5 tests in particular, to scale that number down to a more pragmatic set that's practical and easy to incorporate, as Louay hinted, and she'll explain a little bit of the thinking behind how that subsetting has been done for HbbTV, and which ATSC itself will also align with, because the same reasoning applies to ATSC as it does for HbbTV. So over to Jörn for her presentation on the DPCTF testing.
Thanks, Paul. So just begin with, I'm just checking my screen. Presentation looks okay, and my audio sound good?
Yeah.
Okay, great. I will make a start. Hi everyone, my name is Jörn. I'm from Resillion, and this presentation I'd like to share you more about device playback capability test. So the device capability test, I would like to mainly cover four main parts. So I shall start from CTA Wave device playback capability test suites, which is also known as DPC test suites, followed by device observation framework component, which forms a part of DPC test suite, and it determines pass or fail observation result. And after that, there's a little bit more detail about video and audio observations. And finally, I will explain how the wave testing tools will be incorporated into HbbTV and ATSC 3 testing. So first, I'd like to start from DPC test suite. CTA's WAVE project aims to improve how internet-delivered video and audio is handled on consumer electronic devices. This includes mobile phones, smart TVs, and any other media playback devices. The device playback capability test suite, which verifies device capability defined in DPC specification. These capability requirements for video and audio playback include every sample is rendered and samples are rendered in increasing presentation time order. The startup delay should be sufficiently low. The playback duration matches the duration of CMAP track, and etc. The test suites consist of 4 main parts, which are the mezzanine contents, task contents, test runner, and observation framework. Mezzanine contents contains script that will build annotated test contents from specific source contents, which is compatible with WAVE device playback test suites. The artifacts are added to the test media. For video, a QR code encoding the text strings from the human-readable annotations shall be added to each frame of the source video. Each QR code is placed over the video on each successive frame. For audio, pseudo-random noise and pure watermark will be used. Each audio content is generated based on unique seed source string. Test contents offers test content generated from the mezzanine content in different codecs and variations. The DPC test runner offers an automated execution environment for test following the DPCTF test specification. It uses the test contents from test contents module. DPCTF test runner components provides means of configuring a test session, run tests, and view test results. Last but not least is device observation framework. It determines pass or fail result based on observations taken of tests which are run on device by the test runner. Now I'm going to cover a little bit more about device observation framework, including how to use it. Device observation framework automatically asserts whether the WAVE requirements are met without any manual observations. Open source tools, together with off-the-shelf recording device, afford the tester means to compare the original content with the recorded capture from the device under test. Device observation framework operates on camera recordings of the device's screen whilst running tests under test runner. The test material contains QR codes which must be accurately captured for the observation framework to interpret. For audio, the test materials contains white noise. Capturing audio playback via wired connection is required to obtain a clear audio wave signal and minimize noises such as echo and environment sound. To use DPC test suites, user requires to follow these steps as it presented here. First of all, user sets up camera and equipment in a controlled environment and connects a device under test to the test runner landing page. Then user configures a test session on companion device via test runner configuration page. After that, user manually starts the camera recording and starts the test session. When a test session is completed, user stops recording and manually transfer the recording of the test session to a PC where observation framework can access. Then user runs device observation application by giving it the location of the recordings being downloaded. After that, observation framework automatically analyzes the recording and reports result of each test back to the test runner. After that, test results are available from the test runner so that user can choose either view or download the result from test runner result page. Test tools for video streaming verification is available to most of tests such as sequential playback test, random access test, and switching set test, and etc. QR code detection is used for video observations. The camera is required to capture at least twice the frame rate of the test material to capture most QR codes. Observation Framework processes captured files frame by frame to detect presented QR codes and decode the detected QR code to obtain the information. Analyzing this information from QR codes, the Observation Framework will be able to determine whether or not the wave requirements are met, such as presented frames are in order and reports any missing frames. Now I'm going to demonstrate one of our recorded sequential playback tests. So the test includes pre-test session QR code, which include information of session ID and test code. On the left-hand side of the screen, you will see a mezzanine QR code, which contains information such as contents ID, media time, frame number, and frame rate. On the right-hand side, which shows a QR code which overlaid by the test runner, it contains information such as test status and HTML current time. When the test reaches the end, test runner will signal a status finish event, and an observation framework detects the QR code of status finish, and it's make the observation and push back the result to the test runner. The DPC test suite is still under development, and further capability tests for audio verifications are yet to be added. The audio signal processing technologies will be used in Device Observation Framework for audio observation. The main algorithm we use is cross-correlation. The cross-correlation is a measure of similarity of signal of interest with another signal and gives a measurement of time offset between two audio signals. For audio observation, audio playback test to be recorded from a device under test. A captured audio signal will be compared with the original test material using cross-correlation. To verify every small audio segment is rendered, the original signal is cut into many small segments in same size. Cross-correlating original test samples with the recorded signal shows a significant peak where the matches are found, as is shown here. The position of the peak also gives the time of offset where the selected sample presented in the recording. For selected test samples, if calculated time offsets increase linearly in line with its media time, it verifies that every audio samples are rendered and which are in correct order. Observation Framework compares detected offsets of segments in recording with its media time to determine pass or fail. Finally, I'd like to talk a little bit more about how will wave testing be incorporated into HbbTV and ATSC conformance testing. In HbbTV 2.04 and ATSC 3 reference the wave WMAS. HbbTV and ATSC have existing test conformance suite. There are some interoperability questions have been raised to run WMAS test in ATSC3 or HbbTV environments. It is because the scope of the full WMAS test is very broad and also contains a lot of manual testing. It is known not all the WMAS tests could be expected to pass in the population of browsers in use in receivers in the market today. So WAVE, HbbTV, and ATSC group have discussed a pragmatic approach to scale down the WMAS coverage to a more practical and useful subset. Therefore, subsetting WPT is introduced. Subsetting WPT is a script provides a small subset of WMAS tests for specific purpose, including ATSC and HbbTV usage, and one subset covering for both. This is introduced to be able to run WMAS test in a manageable test runtime so that test execution is practical and affordable. The script starts from a set of tests that's passed on each of the reference browser version and exists at the appropriate cutoff date for the WMAS version to be tested. Then it eliminates all manual tests. At the end, it has the option to add back a small subset number of high priority tests if this is considered essential. After that, it eliminates any specific test identified on a manual curated block list, for example, tests that can't be run on or are not relevant to media consumption devices. For each web standard being tested, select a predetermined proportion of established tests and a predetermined proportion of recent tests appropriate to the web standard. Finally, it's add any specific test identified on a manually curated must-include list, such as tests for high-priority APIs or APIs with known integration problems. The subset script is produced and tested for WMAS 2019 and which is to be extended to other WMAS versions. However, the appropriate number of predetermined proportions are still under discussion, and block list and must include list are to be defined later. I think that's reached the end of my talk. Thank you very much for everyone listening.
Thank you, Jörn.
Thank you.
That's great. Thank you for that. So we've heard today from John about why the wave tests are useful to media playback platforms and why HbbTV and ATSC referenced the wave specifications. We've heard from Louay and Jörn about how the test tools work and how they're being incorporated into the existing conformance test schemes for those standards. And obviously, or as it's come across, this is an ongoing work in progress, and HbbTV members or ATSC interested parties are welcome and encouraged to contribute. The tools are from Wave or open source. Join the Wave project if you want to get involved in the standards development exercise and the scope of those specifications. Testing group in HbbTV are working on the subsetting algorithm and approving the include or exclude lists, and that needs to be completed so that we can include all of this good material into logo plans and certification programs for the future. So that's our set of presentations now, and I think thank you very much to the speakers, John, Louay and Jiang, and I think there's now time for a few questions, Jörn, if we have any that have come in.
Absolutely. Thanks also from my side for these great and very interesting presentations. I've learned a lot about an important topic, and we do have a couple of questions. So I think you can see my screen now, and you're able to get an overview of. So far, we've got these 3 questions. The first one I'd like to read out is 2021 CTA Wave support is listed as in progress. Is there a target time frame for full support of CTA Wave 2021? Who would like to respond?
I don't know, Louay or John, do you have any idea of the progress on the various year versions?
Well, 2021 is required for HB, is the one that's landed in HbbTV 204, I think. So an HbbTV 204 is hopefully published real soon now.
So yeah, so maybe now I understand. It's related to the WMAS 2021, which I marked it work in progress, and it's only the test suite is work in progress. The specification is already published. This is very important, but the test suite for the 2021 is still work in progress, but will be published very, very soon. So apologize that it misunderstood the question, but it's related not to the CTA Wave in general, but to the WMAS, I hope.
Okay, that solves that question. Next one, is it possible to define our own subset of tests to execute in a test runner session?
So that's definitely a question for you to answer, I think.
Yeah. Yes, it's possible. There are two ways to do subsets. So when you use a test runner, the WMAS test runner, you have different options to filter tests, to filter out tests. So you can select dedicated APIs. You can deselect, for example, ECMAScript or WebGL and focus only on specific APIs. This is one way. You can also run tests which only pass on for desktop browser code bases. We say, okay, I want only to run the tests that pass on Chrome and Safari and Firefox for this specific year. This is possible. If you want to fine-tune the subsetting, you can do it, but it's not like via the user interface. As Jan already presented, there is like a subset project which is like going to do more subsetting related to HbbTV and ATSC. So you can programmatically define a script that remove everything which is not needed and only keep the tests which are relevant for specific specifications, like in this case HbbTV at 2.0.4 and ATSC 3.0.
Yeah, that's exactly it. We will make the subsetting script available in one of the repositories, which I think you pointed to, Louay, didn't you? And that script will allow somebody to take that as a basis and modify or create their own include, exclude list if they wish to as well. So I think, yes, totally possible to do that.
Okay, thanks for adding this. By the way, we have still a bit of time, so if you have any further questions, please keep sending them in through the Q&A section of the toolbox. And last one, at least at this stage for Louay, how reliably do the tests to the end without getting stuck somewhere in the middle of several thousand tests?
Yeah, this is a very good question. And indeed, if you run tests on embedded devices, so you should expect that some tests may break your browser and TV. And this was, there is a feature for this because we know this. And we decided to implement a new feature, which is like, we call it test continuation. So if you run a test on a device and for some reason one of the tests break the test session, so you can restart the TV and continue from the same point where the TV is crashed. But on top of that, we offer, as I mentioned, other features like you can only run tests that pass on a desktop browser code basis. And in this case, you can maybe reduce the amount of the tests that may break your test session. I think from our experience, if you select desktop browser code basis as a filter, you may face 1-2 times there is like a break or crash in the test, but you can recover it and continue where you stopped. And for the next run, you can add this test on the blacklist. So there is a blacklist. You can say next time when I run the test on my device or the same device, or maybe device from the same manufacturer but other like device model, you can skip those tests which are causing to crash.
Okay, anyone else would like to comment on this?
No, I mean, I think in general, the subsetting exercise is a little bit of an acknowledgement that, you know, we need to get this down to a more manageable set. Obviously, there are different reasons why it might get stuck. A flaky test is one that we can put on the exclude list. Obviously, if there are problems with the implementation, then that's something that the test set are designed to find. And as Louay said, there's ways to continue and resume, which is really very helpful.
Okay, so we've just got one more question that has come in. Is there a tool or tools to draw QR code on my own video content to use it as an alternate Matsony content? I guess drawing QR code frame by frame takes so long time.
Yeah, and do you
Would
want to say anything about the mechanism for generating the test content on the DPCTF, or shall I?
Yeah, that's fine. So we do have a script on the mezzanine contents GitHub repository, which can be extended to use to insert the QR code on the video contents of your own choices. Yeah, then it should be extended to become a test contents by encoding and apply the dashing to become a test contents. Then it can be pulled by test runner.
Okay. Last one at this stage that has just come in. What test report formats are available? Can it generate GUnit or equivalent XML so can be easily integrated with CI/CD tools?
Yeah, maybe I can answer this. So the test formats, we offer two formats. One is JSON, and then from the JSON we create HTML, like human readable format. The thing is, we try to be compliant with WPT test runner, and we use the same format. We didn't change the format, so our results or test results are compatible with WPT. So you cannot use it directly in GUnit or integrate it, but I think with a JSON format, if you write a converter, you can easily integrate it in other tools, but it's JSON format.
Okay. Right. I think that wraps it up. So thank you very much for watching the webinar, and in particular, of course, I'd like to thank the speakers. Oh, there's one that has come in. Let's do that. We're live here and add that to the list. Would there be any limitations to executing test runners in parallel if deployed in cloud? Last question of the day. Who would like to respond?
Louay, I think I should. Louay?
Yeah, I can respond to this. There is limitation, and maybe I forgot to mention in the slides that the online versions of the test runner are only for are not designed to run for production. It's just for quick like play around the test runner and so on. But if you want to use the test runner for different parallel sessions or many sessions and so on, we recommend you that you host your test runner by yourself. And this is very easy task, because there is like a Docker deployment. So with few steps, you can easily deploy the test runner and run it on your premise, or even deploy it on AWS or other hyperscalers. It's easy to run. But the tests on the online test runner, please, it's not for production. Just use it for if you want to play around the test runner.
Okay, I think that was helpful. So thanks again to all of you, and just a couple of formal remarks before we're closing the session. As I already mentioned in the beginning, there will be a YouTube recording available of this webinar on the HbbTV Association's YouTube channel, and the presentations held by the speakers will be made available as PDF documents from the HbbTV Association website. You'll all receive the links to those documents in an email sent to you 24 hours after this session automatically. And of course, a couple of announcements are there for you as well. You might have already seen and received the save the date message for this year's HbbTV Symposium. It's taking place on November the 29th and 30th in Naples in Italy. So make sure you mark that date in your calendar. And I'm sure this will be a great event again, following last year's session in Prague in the Czech Republic. And as usual, this webinar session and series is made for you. So HbbTV is very happy for your suggestions for further topics. Send an email to webinar@hbbtv.org with your proposals, your ideas, your comments, anything you'd like to comment on. And for updates on HbbTV related developments, please visit the Twitter site of HbbTV and the HbbTV group or the HbbTV site on LinkedIn. That takes me to the end. So once again, thank you very much for taking the time to be with us today. I think we've had a very sophisticated and interesting session. Thanks also to everyone who submitted their questions. This made it really interesting as well. And so I hope you spend a nice day, a nice evening wherever you are, and have a great week. Thank you again. Take care and see you next time. Thank you very much.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.